Ladies and gentlemen, welcome to our exploration of strategic use of coke in blast furnaces. Today, we are embarking on a journey into the intricate world of optimizing coke quality and granulometry. Our aim is to uncover the profound effects these factors have on critical aspects such as blast furnace stability, gas utilization, efficiency, and overcoming operational challenge such as reduced tapping efficiency and potential flooding. Today we are going to discuss on a flooding. As our second slide shows that in large blast furnaces maintaining the right coke size and quality is very crucial, especially in order to prevent flooding at the 2 years level and ensure efficient operation. It is very important. Now, reduction in coke size increases the risk of flooding. As we know, as these small sizes choke the downward grid and increase the holding of metal and slag in those regions, and due to which we observe a huge resistance to the gas flow. And as in this figure, it is nicely illustrated in a furnace condition, in a furnace of 5500 meter cube. It is already shown that in order to prevent flooding by maintaining by managing the ratio of gas velocity V to maximum gas velocity without flooding, that is taken as Vf below 0.95. And I think this is a graph which guides the operator to a great extent that what is the limit. Sampling results suggest larger coke sizes ideally exceeding 45 mm at productivity of 2.4 and 50 mm at productivity of 2.5 are really favorable for reducing flooding. Now coming to the our conclusion, as we can say that managing coke size and quality is crucial for optimizing blast furnace. Ensuring that the coke used is of the correct size and quality is essential for the smooth operation of the blast furnace, ultimately leading to increased productivity. The size of the coke used near the tuer plays a significant role in preventing flooding, as we have shown already in the previous slide. That is, flooding within the blast furnace is especially getting contributed by the bigger size of coke. Larger coke pieces are more effective at preventing flooding, whereas smaller coke sizes increase the risk of flooding. The size of the coke used directly impact the productivity of the blast furnace. Optimal coke sizes, typically over 45 mm at the productivity of 2.4 and over 50 mm at the productivity of 2.5, are necessary for the maximizing output and efficiency within the blast furnace, as I shown early in the previous slide. Enhancing the quality of coke, including factors such as strength and reactivity, is essential for improving overall productivity. By focusing on improving coke quality, blast furnace operators can achieve higher level of efficiency and productivity. Additionally, keeping critical component like the bird nest and deadman clean helps reduce the generation of a small coke pieces, further contributing to the productivity improvements. And thank you very much for your valuable time.